This is the volume, the POMAS September minimum volume. You know, how the exponential, it's fitted to a whole bunch of different curves, exponentials, Gompertz, log fits, different curves to try to fit it, and then the actual data here. So the trends are all coming down. So because there's lots of fluctuations, you know, it's very difficult to call a particular year, but the ice is definitely on its way out very quickly. And just to remember, this is showing all of the different months, how the ice volume is declining. So this is September that we just looked at, the green line. This is what happens in August, the loss in August, and this is the loss in October. So these are the months framing September. So when the ice is gone, we have a blue Arctic or blue ocean event in September. You know, then quickly it'll extend to 3 months duration. And then within a few years later, it extends to 6 months. And then, but all these curves are heading down. So we're heading to a point where we'll have an ice-free Arctic year-round. And, you know, that could take a decade after the first event or first blue ocean event. And then we've transitioned through an abrupt climate change, and global temperature will be much higher, and so on. So there's evidence in the paleo records that this has happened over a decade or two. And this is what's happening with the jet stream. So you can see North America here, Alaska. So with all that warm water over here, there's no way this is like a mountain or a ridge blocking the jets. So it causes the jets to be wavy like this, and then that propagates around by teleconnections, and it's wavy all the way around. And you can see these areas that have splintered off of the jet. So here we have, this is a high pressure area, because the high pressure, the air is moving from the high to the low pressure, and then it boots around to the right because of the Coriolis force. This would be a low pressure area. The air is coming in, deflected to the right around a low pressure area. So there's lots of broken, fractured behavior of the jet stream. This is a paper, Hansen et al., and it just shows some of the curves, global land-ocean temperatures. It shows the anomalies. So 2014, warmest year, 0.68 degrees above the norm. And 2010, second warmest, 2005 warmest. 2015 is probably going to blow all of these away. And I'll show you here's some data from 2014 with the numbers being much higher, the anomalies. This is the winter, spring, summer, fall. So the anomalies do vary. You know, they're highest in the fall in this case, and in the spring here. And you can see there's also some data here. This is land surface temperature and ocean sea surface temperature. It takes longer to heat the water, so the land temperatures rise more. I just wanted to show you a couple things here. You know, the idea of this pause or hiatus doesn't, you know, it doesn't really exist. For June 2015, the anomaly is 0.76. For May, it was 0.73. This is showing the, just a second here. My fingers don't reach.